Okay, so let's move on to the second part of the challenge problem for chapter 22. Okay, so here we have on the next, we want to write the problem to simplify this expression. The first is find for different value of the b that could choose so that the answer to the question is integer. Okay, so it's the same thing. So x equal to the b plus the x. So now we have the x squared minus x minus b equals to the 0, right? So if we want it to be answer to be an integer, we can see is x minus the n plus 1 and the x plus the n, right? So in this type of the solutions, we have x equals to n plus 1 is an integer. So that's why the format, the format of the b should be n times n plus 1, right? So that it's product of two consecutive integer numbers. So we can see b equals 1 times 2, 2 times 3, 3 times 4, 4 times 5, so on and so forth. Okay, b. So what must be true about the b in order to answer is an integer? Okay, so we already find a very general case on the A for question A. C is determine the largest value of the n that is an integer. Okay, so n less than this. So here n equal to the integer m and the m plus 1, right, should be less than the 4 times the 10 to the 6, right? So you can see if it's 2 million, right, is this one is the 2000 times 2000, right? So the maximum n is the 2000 times 1999. And for the d, so if this is equal to a positive integer, that this one also equals to an integer. Okay, let's see. So let's see the x squared minus the x minus a equal to 0, right? So we know the x squared minus the x minus the n plus 1, right, equals 0. So we can factorize x n plus 1 and the x plus n equals 0. This is the first case, right? Now the second case, let's see. A equals, so the x equals the root of the a minus the x, right? Minus x. So now let's see, we have the x squared is equal to the a minus x. So we have the x squared plus a minus n, then n plus 1 is equal to 0. Then we can have the x plus the n plus 1 and the x minus n equals to 0. So that's why, because the square root, right, the square root is also greater or equal than 0, right? So the negative answer cannot be the true, so x equals n. So that's the answer will be yes. It's also integer. So we want to show that the a is positive, this one becomes this one, right? So we know how to solve it. So this one belongs to a quadratic equation. Is a solution of a quadratic equation. This one is also a solution to a quadratic equation. Right? And if we say they belong to the same quadratic equation and there is only single solution can make x greater than 0, x greater equal than 0, then they must be the same, right? So let's see the first one. So x equals to the a plus the x. The second one is x minus 1. Right, is equal to the a over 1 plus the x minus 1. Okay, then this one is makes us to a equals x a over x, right? Now let's see, they belong to the same quadratic term equation. Okay, so this is the x squared minus x minus a equals 0. Okay, so this one is x squared minus x then minus a equals to 0. Okay, so they both belong to the same type of the quadratic equation, right? Now we need to prove they only have one positive solutions. Delta is equal to 1 plus 4a, right? So you can see the x will be equal to 2 1 plus over 1 plus minus 1 plus 4a, right? Since this one minus something will be less than 0, so it's cancelled. It's not true, right? So here you will also have the same solution. That's why they both equal. Next. Okay, so this type of the cyclic term, okay, is very special. So I can show you how to do it. Okay, so let's the first is we can cancel out the same thing, basically the conclusion. Okay, the conclusion is this type of the cyclic format can leads to a quadratic equation with xyz. Okay, so now let's do it. So let's see, we wanted the xyz, right? So now let's do some manipulation. Y over y, 1 over y is 4 minus x. 1 over z is equal to the 1 minus y. And 1 over x is equal to the 7 over 3 minus z, right? If we product them together, we have the xyz on this side, then we're expanding on the other side. Okay, let's expand this. It's 4 minus x minus 4y, then plus the xy. Okay, let's further expand this. Now we have the 28 over 3, then minus the 7 over 3x, then minus the 28 over 3y, then plus the 7 over 3xy. Okay, now we have the single term. Now we have this one is minus the 4z, right? And we have plus the xz, then plus the 4yz, right? And then minus xyz. Okay, so you can see we have the xyz and the xyz. Now our focus is to focus on cancel these sections. Okay, these two sections. Okay, so how to cancel these two sections? Still, we need to starting from the here. Okay, so we need the xy term, right? And the yz term. Okay, so now let's see. So we have the, let's do it. So we times y. So the first we have 1 equals 4y minus the xy, right? But we need the 7 over 3xy, right? So 7 over 3 equal to the 28 over 3 of the y minus the 7 over 3 of the xy. Okay? So you can see 7 over 3 of the xy here, right? And the negative 27 over 3 of the y. Did you see it? Okay, so this means the 7 over 3xy minus 28 over 3 of the y is negative 7 over 3. This is the 1. You see it? Now the 2. Let's see, okay? So the 1 is equal to z minus the yz, right? So we have the 4yz, right? Okay, now times 4 is equal to 4z minus 4yz, right? let me use another color, is 4yz and 4z. Did you see it? Now you can see the 4yz minus the 4z equals -4. Okay, now the third part. Let's use another color. So it is the 1 equal 7/3x minus xz, right? So we have 1xz, see? 1xz and 7/3x. Now we have the xz minus the 7/3x equal to -1. Okay, now you can see this one on the right side, right? We can simplify as the 28/3 minus 7/3, then -4, right? And the -1 minus xyz. So equal what? Equal 3, it's 5. 5 is 15, 15 is 22, 22 is 6, right? And minus the xyz. Okay, now you can see we have a good quadratic equation. Xyz is equal to 2 minus the xyz. Okay, now let's using xyz is t, right? Now we can have the we can do the 1 is equal to 2t minus t squared. Now it's t squared minus 2t plus 1 equals 0. So we can have the t equals 1. Okay, so this cyclic is very special, remember, okay? Next. So we want to solve this problem, okay? So now let's see. So it's the y. Let's see, this is the y equals the √3, then 3 minus 2y. Okay, now let's cube on both sides is y cube equal to 3 minus 2y. Then we can see is the y cube plus the 2y minus 3 is 0. So you can try, right? Because it's a cubic equation, not easy to answer, but we can try some the rational roots. Okay, y equal 1 is definitely the answer, right? So that's why we can use the long division to do it. So we can use the y cube plus the 0y squared, right, plus the 2y minus 3 divided by y minus 1. So we can see the y squared is a y cube minus y squared. Then it's the y squared plus the 2y. Then plus the y is the y squared minus y. Then we have the 3y minus 3. So here is plus 3. So that means the cubic function of this can be factorized into the y minus 1 and the y squared plus y plus 3 equals 0. So we can see we have a solution of 1. For this part of the quadratic, delta is 1 minus the 12 is -11 less than 0. So there's no real roots, right? So the answer will be 1. So next. So normally when you see it's the radical form, right? It's 3, you can see it's the a plus b, and there is another one, 3 is the a minus b. You add together, it asks you what's the results here, okay? Normally we do adding more variables, but because all the manipulation of the factorization is x to the n is a positive integer, we can do it. But it's a fractional, it's really hard. So that's why what we do is we introduce more variables, okay? So x equal to the cubic root of the 18 plus 5, 13. So this one tells us the x cubed is equal to the 18 plus 5 root 13. Then y equals to the cubic root 18 minus 5 root 13. So we have the y cube is equal to 18 minus the 5 root 13, right? So now we can see the question is asking us what is x plus y, right? Okay, now what you can see, we can manipulating the problem here, right? So let's see, okay? So the x cube plus the y cube is equal to the 36, right? So the x cube and the y cube, we can do the x plus y, right? And the x plus y of the cube minus 3xy equals 36. So as long as we solve the xy, we solve everything, right? Let's see, because xy is simple, because here you can see it's the 18 square minus the 5 root 13 of the square is equal to the 324 minus the 325 is negative 1. That's the beauty of this kind of constructions, okay? It's the difference of the square. So now you can see the x plus y is equal to t, okay? So we have the t, and the t square plus 3, right, is equal to 36. Okay, now we become a cubic function, right? Okay, so for this cubic function, we have the okay, so we can see it's t cube plus 3t minus 36 is 0. Then the t is 3 is a solution, right? So 27 plus 9 is yes. So t is 3 is a solution. So we need to prove maybe to see whether we have other solutions, right? So t cube plus 0t square plus 3t minus 36, then t minus 3, right? So we have the t square and t cube minus 3t square. Then we have the 3t square plus 3t. Then we can do the plus 3t, though 3t square minus 9t. Okay, it's 12t minus 36, so it's plus the 12. So this is the answer. So this one we can reduce to t minus 3, then times the t squared plus 3t plus 12, okay, equals to 0. So we have t1 equals 3. For this part, you can see the delta is 9 minus 48 less than 0. So there is no real solution. So the final answer, x plus y, is equal to 3.